getting recorded. Okay, I'll put a couple of you on air. Yeah, please give a quick introduction, just about yourself briefly, and we'll go from there, guys. Okay. You're hearing the voice echo. How about others, guys? How's others doing? Is the voice okay, or are you having any issues? Okay. Is it totally unbearable, guys, or is this something that you can bear for today? Because it looks like one of my earphones is not working, and I have another one here as a backup. That is what I'm using. If you're able to bear it for today, okay. Oh, okay. Sounds good, guys. Okay, so I have my mic a little bit away. Just in case that's better. Just in case it's it bothers you, let me know. I'll try to keep it a little bit away, guys. Okay. So having said that, let me come back and unmute Abhinav here. Abhinav. Sorry. Can you go ahead and introduce yourself? You're on air, Abhinav. Oh, you don't have a mic. Okay. All right. Come here. Let's see if Aditya is able to introduce himself here. Aditya, you're on air, buddy. Can you give a brief introduction about yourself? Oops. Okay. Any volunteers, guys? Anybody who has a mic and everything set up, can you just come on air here? I'll probably take one quick introduction and move on to today's topics. Anybody willing to come on and just give a brief? Okay, Srujan, thank you, buddy. Just give me 1 second here. Let me find you here. There you go. Oops.
Hi, Navin, can you hear me?
Hey, Srujan, go ahead, buddy.
Yeah, so myself, Srujan, I'm from UK. I'm from SAP and Salesforce background. I just started some of the research on Hadoop quite a bit. That's all about. And I have got nearly about 2 years in the industry. This is my first instance on Hadoop.
Very good. So you're already into SAP and Salesforce, and now you want to get into Hadoop. Okay, very good. Which city you're in, Srujan?
I'm in Reading, quite close away from London City, just 40 miles away.
What is that? What is the name?
Reading. We probably call them as Reading. Reading, R-E-A.
Does it look like?
No.
Oh,
Reading, R-E-A-D-I-N-G, Reading.
Oh, okay. Oh, that's the name of the city?
Sorry?
Is that the name of the city?
Yeah, it's the name of the city. It's a bit awkward, Reading, but we call them as Reading.
Gotcha. That's cool. It's not awkward. It's just cool. But interesting. Very good, Srujan. Thank you, buddy. So it looks like you're into SAP and Salesforce. That means you're right now playing badminton and probably, what should I say, squash. And now you want to get into the world of cricket, don't you?
Yeah, ideally.
All right. Just kidding, buddy. All right. Good, Srujan. Thank you again. I appreciate that. So, okay. So what we'll do is I will go ahead and get back here. Since I've lost a few minutes here, I will go ahead and put you back on mute. And we'll continue with our topics today, and we'll try to maintain the similar discipline on a daily basis where we get a quick introduction of one or two guys, and we'll go ahead and continue with our topics, Srijan. That's going to be the plan. Fair enough?
Thanks very much. Thanks.
Excellent. Outstanding. Thank you very much. Appreciate that. Cool. So that is Srijan, guys. So he's in UK, and hopefully he's having fun there. And let's get back in here. So for those of you who may have already attended the demo in the last couple of sessions, we briefly discussed about what is big data and things like that. So let's take a little deep and try to get a slightly deeper look and rather more technical understanding of what is Hadoop, guys. Okay, and everybody okay with my voice, guys? Could you just give me a quick just type in a Y if you guys are doing okay with my voice. I have Biswanath, he says it's not audible, so I'm just trying to verify that, guys. Okay, great. Thank you, guys. Here and there, you'll be finding me asking for these acknowledgements. Just type in a Y or a S or an N for no, and that'll kind of help me in staying in sync with you guys, folks. Okay. So having said that, again, let's go back and get back here. So start with big data. Before I start, guys, just a quick question again. Sorry to bother you. How many of you have already attended the first one or two sessions that I have given earlier, guys? Yes and no. Just type in a Y or an N for a yes or no. Great. Okay. I see a bunch of guys. Okay, so Prasad, just stay tuned in. For those of you who did not attend, just stay tuned in. I'm going to be starting from beginning again, so you won't be missing. They will be sharing the recordings and everything with you, so you should be able to catch up, Srijan and everyone, and try to catch up on that. And we'll try to cover what we have covered already in the demo sessions, guys. Okay, so let's get started with big data, guys. Before we get into, we understand what is Hadoop. Let us try to understand why Hadoop is important and what is the problem it is trying to solve, and that's where the story of big data starts, guys. Okay, so here's a slightly technical definition. It is a term applied to data sets whose size is beyond the ability of commonly used software or hardware to capture, manage, and process the data within a tolerable amount of elapsed time. Slightly technical definition, but let's take a slightly friendly understanding of that one, guys. Okay, so imagine this is your laptop, and imagine, pardon me. For those of you, I may have covered these things, guys. Just bear with me here. Abhinav, if you're saying, are we recording this? Yes, I'm recording that. So all the sessions will be recorded and they'll be shared with you, buddy, if that's what you're wondering. Okay. So gentlemen, ladies, imagine that's our laptop. Imagine this is about 1 GB of data. And let's go ahead. What do we do? Well, if you have 1 GB of data, it's easy for us to go ahead and actually, let me choose this one. Or let me choose this one to be more precise. That's 1 GB of data. It's easy for us to go ahead and store it inside a laptop. What does that mean? Well, that means we're able to capture it. Then what can we do? Well, we can go ahead and write a program. You can write a .NET, a Java, or maybe an SQL program or things like that. Imagine you write some kind of program, and what do? You can go ahead and process it. Okay, what does that mean? Well, what that means is we're able to manage or rather process the data. And imagine what is happening is when we process the data. Cool. Let's come here. Imagine, for sake of simplicity, come here. It's taking 10 hours of time, okay, to process the data. Now, for a moment, if we come back here, what we are looking at the definition is we're able to capture, we're able to manage and process the data within a tolerable amount of elapsed time. What is it? Well, this is some data we're able to process, we're able to capture and process within a tolerable amount of elapsed time. Imagine a scenario where our users come back and say, hey buddy, we need this processing to be done in 1 hour. Okay, so that is 1 hour. Then that's when it fails the condition where we are saying we need it in 1 hour, whereas it is taking 10 hours. So what is happening? Well, it is only 1 GB of data here. Cool. So let's come here, say that's only 1 GB of data. And we're able to capture, come here. We're able to capture it. We're able to process it. But what is happening where we are failing is, we need it in 1 hour, it is taking 10 hours. So in other words, we are not able to process it in tolerable amount of elapsed time. What is that? That is big data. Gentlemen, ladies, not only should we be able to save it successfully, but we should be able to process it within our amount of time. What do we have? Well, we really have small amount of data, but what is that? That is what is the definition of big data. If you are even unable to process it within tolerable amount of elapsed time, that would be called as big data, guys. Okay, let me do a little bit of cleanup here. Cool. Now let's come here. Let's take another scenario. Imagine you have, let's say, cool. Come here. Oops. Come here. Select that and select that, and let's say that's 100 terabytes of data. Okay. What do we do? Try to plug in or store the data into 100 terabytes. Boom. You can save it in a single laptop. What's happening? Well, right away. What's happening? That data is beyond the ability of our hardware, either software or hardware, okay? To what? To capture. Forget about managing and processing. We're not even able to capture or store the data. What is that? That's a rather, it's an easy way. We're right away looking at it, and we're saying that's really huge amount of data, so it's easy to say it's big data. But the catch is in a tolerable amount of elapsed time, guys. Okay, here we're not even able to capture the data. Forget about the tolerable amount of elapsed time. And what is that? Well, again, that's another perspective of big data, guys. Okay, then we have 3 V's here. Okay, what are the 3 V's? Well, if you remember, come back here. Come here. Imagine this is the timeline. And what's happening? Well, this is something like, maybe I should say, I do not know if it is really right to say 1 BC, but continue like that. And somewhere here, come here, is 2003. Okay, and what else is here? Well, imagine this is 2012. What's happening? Here is what is happening, guys. Okay, let's come here. Imagine if one of us were to take all the data that was generated by the entire mankind, right from the beginning of the time till 2003, that was supposed to be, come here. Let's see if I can write it here. It was supposed to be about 5 exabytes of data, guys. Okay. Okay. And what happened? Well, starting from the year 2012, come here. Starting from the year 2012, okay, in just 1 year, right? What happened? Well, here's what happened. We have generated, come here, 2.7 zettabytes of data, guys, okay? That is what has happened. In other words, okay, for those of you who are kind of, a quick recap again, for those of you who missed my earlier session, guys, about 1 terabyte equals to 1,000 gigabytes. 1 petabyte comes next, which is equal to 1,000 terabytes. Then comes 1 exabyte, which equals to 1,000 petabytes. And then comes 1 zettabyte, which equals to 1,000 exabytes. That's okay. So what is happening is, imagine this. You see, this dot is the amount of data which was generated from starting of the time of the from the time when mankind started documenting some data up to 2003. That is the amount of data, which is 5 exabytes of data, which was generated by the entire mankind, guys. Okay, if we somehow managed to digitize it and put together, what happened? Starting from the year 2012, every 2 days, the mankind has started generating that amount of data. In other words, come here, take a look at this one. In the year 2012 alone, that is the amount of data that entire mankind has generated, guys, okay? So what do we say? Well, this is exponentially huge. If we compare this dot, if we compare this dot with this circle, that is exponentially huge. What is that? Well, at a fundamental level, or rather at the core, what we are looking at is an exponential volume of data is what we are getting generated, guys, okay? And another important point is, it seems every 2 days we are generating this amount of data, starting from 2012, okay? Well, and what that means is the speed or the rate at which we are generating the data is really, really huge. What is that? That is called the velocity. But where is this data coming from, guys? Well, today there's a new kid in the block who is the internet, guys, okay? Remember, companies were like fishermen. We have given up. Imagine companies are like fishermen. What are the fishermen doing? Fishermen are going to the databases. Okay, where's the database? Well, here's the database. Come here. Here, let's say, put it here. This is the database. What would a company do? Imagine you're developing a web application or something like that. You'll go ahead and develop something like a data access layer. There's your business logic layer. There's your service layer. There's your UI layer. And this is where your end users are. Cool. And what do your end users do? Your end users are looking at the data. This data is coming from the database or the data warehouse. And they're looking at the reports. Cool. So let's go down, write it here. Reports. From the reports, they get insights. What's an example of reports, guys? Well, imagine this is like a retail industry, and your users are looking at a report which is indicating, hey, you know what? Our company, it looks like we're making most of the sales during the weekends, and it looks like there are certain age groups. Maybe the teenagers are making most of the purchases during the weekends. That is what the interesting insights they're finding out of the reports, guys. Okay. So what do they do out of those reports or insights? Well, come here. They will make decisions. Come here. Decisions. What's an example of a decision, guys? Well, imagine the company now comes up with a decision saying, hey, guys, you know what? Since teenagers are making most of the purchases during the weekends, let's go ahead and offer more discounts. Maybe an example of a decision. Another example of a decision could be, since teenagers are anyhow making purchases, let's not focus on them. Let's try to give discounts to other age groups, other age ranges, and let's offer more discounts to them so that we can increase our sales and things like that. Okay? But what is happening? Here is the catch. These insights they're getting from a database. Okay? Databases are like rivers of the world. There's only 10 to 20% of the water in the rivers of the world. Okay? There's a new kid in the block today. Who's that new kid? Well, come here. Come here. That is the internet. Cool. Okay. What's happening on internet? Well, you have your YouTube, you have your blogs, you have your Flickr and other Picasa and other things. You have other sites. You have other kinds of data which is there and things like that. Okay. What do companies want to do? Companies today want to get the same insights. Okay. What they are getting from database, now they want to go to this internet and be able to generate the reports. From the reports, they want to be able to get insights, and from the insights, they want to be able to make the decisions, guys. In other words, today there's a new kid in the block. Who is that? That's your internet. Internet is like the seas and oceans. 80 to 90% of the data in the world is on the internet, guys. Okay. What do the fishermen want to do? It's not just enough if they are able to go to a river and find the fish. Today, they want to be able to get the fish from the seas and oceans. If you can find fish, which is insights from a database, you can find lots of fish in your seas and oceans, guys. Okay. What's an example of that? We will see that in the coming up months, guys. Okay. But gentlemen, ladies, am I making sense, guys? Could you just give me could you just type in a Y and things like that? Just type in a Y, just to give me an acknowledgement. Is that making sense? Are you able to catch me? Cool. Okay, so in other words, that's the way to relate it, guys. We'll dig a little deep into it, and let me do a little bit of clean up here. Cool. Okay, now, so what do we have, guys? Well, big data, or rather a friendly definition of big data is equal to V, oops, come here, equals to V plus V plus V equals to 3 V's. Okay, that's one way to remember, guys. Okay, we have seen a couple of different perspectives of big data, and what is happening? Well, we said this is the exponential volume of the data that we have started generating. Okay, what's happening in a very small, every 2 days we're generating the entire data that the mankind has generated up to 2003. That is the speed at which that is referred as velocity. What's happening? Internet has become internet, and other sources of data has become the new source of data. What is that? Well, the fishermen were just going to rivers and finding fish, and they were happy. Today we are saying there's a new way to do the fishing. It's seas and oceans. That's your internet. That's your other sources of data. What do you have? You have different varieties of the data. That's where it comes in unstructured data. Okay, what is that? That is your XML, that is your JSON, that is your HTML, things like that. What is that? That is the third way. Gentlemen, ladies, everybody okay with this slide, guys? Can I move on to the next slide, please? Cool. Okay, let me make a little bit of progress here. Let's see, here's a quick example, quick snapshot of some of the examples. So that is the 5 exabytes of information that we were talking. From the dawn of civilization through 2003, if somebody were to digitize it, that's how much it will become. Today we are generating every 2 days, guys, okay? What's happening? Twitter processed 340 million messages. Again, what is that? A message in a Twitter is probably equal to 350 or 500 rows in their internal database, okay? And what are we telling? Well, you multiply that with 340 million, multiplied by maybe 300 or maybe 500 per week. What's that? Imagine the number of rows they will become. 1 billion rows in a week are getting plugged into their database, okay? Oh, that's an example. That's an exponential increase in the volume of the data, guys, okay? So what used to happen was a year or 2 years back, or maybe a couple of years back, to be more precise, that amount of data was getting plugged into a database every maybe 2 years, 3 years, or maybe 5 years like that. Today, that's happening in a day or a week, okay? And Facebook, again, 1 billion likes there. Amazon, 1 billion objects are getting stored. Again, eBay, 90 petabytes of data. Because what we are looking at is an exponential, a phenomenal amount of data is what the companies have become capable of getting from various places such as internet and other sources of the data. Guys, okay? It is no more. Enterprise information measure is no more in terabytes and petabytes, but soon it's going to be exabytes and zettabytes, guys, okay? Everybody okay with this slide, guys? Is that making sense? Are you with me? Could you just type in a Y, guys, if you're okay? Okay. Okay. So now we do have a lot of data, but what is the problem with that? Let's try to understand what's the problem, guys, okay? If you have, imagine this is your laptop, cool. And if assuming we just have 1 GB of data, okay, that's 1 GB of data. What could you do? Well, you can go ahead and save it into your laptop, okay? But imagine you have, rather, we have, come here, cool. That's about 100 terabytes of data. What do we do? Well, oops, come here. You try to save that, boom, you cannot save that amount of data in your laptop, guys. Okay, why? That is 100 terabytes of data. Oops. So what does that mean? Well, what that means is storing is one of the problem, guys. Okay, if you're unable to store, we cannot process it. Okay, if you're able to store successfully, how would we do? Well, you can go ahead and use multiple servers. Imagine, come here, we'll go ahead and say that is server 1, server 2. Traditionally, what enterprises are used to do is, they'll go ahead and take your data. Imagine you have 100 servers, and that is really 100 terabytes of data. Come here. Come here, that is 100 terabytes of data, guys, okay? So what do you do now? What we can do is you can go ahead and split the 100 terabytes of data into single terabyte, 1 terabyte, maybe 100 times 1 terabyte, and then go ahead and save the data. Okay, so let's come here. Let's go and select that. Let's say that is 1 terabyte, and let's say that's another terabyte, and let's say that's another terabyte, and so on. Imagine we have somehow managed to split that 100 terabytes into small 1 terabytes of 100, and then we are saving the data, guys. Okay, what is that? We have successfully stored it. Oops, come here. Oops, cancel that. Come here. We have successfully stored it, but then how do we process it? Okay, so what will happen? Well, processing of it is another problem. Storing of itself, splitting the data and storing itself is very, very complex, and processing it is will be even more complex, guys. Okay, what is that? That is the problem with the big data. Everybody with me, guys? Are you okay with me? So it's like saying you have to be a mechanical engineer to drive a car. If you have lots of data, what do you need to know? You need to understand how to split the data, how to go ahead and save the data into different computers and things like that. And what happens there? Well, when you try to understand how to split the data and how to save it, there comes concepts such as multi-node communication, multi-process communication, multi-threading communication. And as you're saying, what could happen? Your service could go down. What will you do? Networking concepts and many other complex concepts come. What happens? Well, that is again the problem with the big data. You need to be a mechanical engineer to drive a car. Only when you are a mechanical engineer, you can go ahead and store it, you can process it, and you can go ahead and process the unstructured data also, guys. That's another perspective of the big data, guys, okay? Or rather, those are some of the problems of the big data, guys, okay? So having said that, let's come here. Okay, so gentlemen, ladies, before I proceed, is the pace okay, guys? Are you guys able to follow me? I just want to check and see if the pace is okay, and are you able to catch up to the speed, or am I going too fast, too slow? I know I wasted a few minutes in the beginning because of my headphone and things like that, but pardon me for that. Okay. Okay, at any point of time, if you find I'm going a little fast or slow, please feel free to let me know, guys. Just give me a friendly update and I'll try to handle it. Okay, so let's come here. We have different varieties of data. What is structured data? Structured data is the reverse of the word. What do we have in a structured data? Data is well organized. Assuming student data is a table or student is a table. We know the column names. We know the relationships. We define the constraints. We know the data types and things like that. It is well organized. What is that? Well, that is the reverse of the word. What's happening? This is where the companies are traditionally going. Your database and data warehouse is the place where they're going, and they're trying to generate the reports from the data that they have in the database, and they're trying to get the insights out of that, guys, okay? But what's happening? There's a disruption which is happening. Disruption in the way the business is being done. What is that? That's where it comes in unstructured data. Cool? What is unstructured data? That is your seas and oceans of the world, guys, okay? Where is this? Well, internet and other sources. They have become the seas and the oceans. If you can find fish in rivers, there's a lot of fish we can find in seas and oceans, guys, okay? But what is happening? Data is organized in an arbitrary manner. It is true that we can find a lot of fish, but what's happening? There's a lot of storms. It's not easy to navigate. It's not as easy as it is to navigate in the rivers, guys, okay? It's much more difficult here. We do not know anything about our data. It is not predefined. We do not know what is the data type. We do not know what is the column names, relationships, constraints, and anything, guys, okay? The types of the data could include images, videos, audios. There's a lot of data which is available on the web. Everybody's opening up their data, and organizations want others to go ahead and look at this data and see if they can find some interesting patterns and things like that, okay? A quick example is your resume. If you take a look at your resume, it does not have a table. It does not have a column name. It's just free text and things like that. That is referred as unstructured data. Other forms of unstructured data is your images, videos, audios, and other documents, guys, okay? Then we have what is called semi-structured data. Okay, if you're familiar with what is called XML or JSON, that's an example of semi-structured data. There is some hierarchical structure associated within it, although it is not completely, it does not completely tell us everything about the data. That is referred as semi-structured data, guys, okay? Your structured data, data which is in your database. Come here, come here. Let's say this is your data within the database, okay? And then, come here. Here is our data. Oops. Select this. Here's our data, which is in the seas and the oceans, guys, okay? And in the data in the database, we know the schema, which is the relationships, constants, and things like that. Whereas when you're getting the data from somewhere outside, we do not know anything. We do not know the schema of it. That is why it is referred as unstructured data. Data such as XML has some kind of structure. That is why it is referred as semi-structured data, guys, okay? Data cannot be processed as effectively as the structured data. When you know the complete schema, here, it is slightly more easy than compared to the data we have where we do not know the schema of it. Okay, so it is slightly more easy when we process the structured data or the data in the database compared to the data where we do not know the schema as what we are trying to convey, guys, okay? What's an example of an XML? We will have a look at that in a second, but that is what is the structured and the semi-structured data, guys, okay? Is that making sense, guys? Everybody with me? Am I making sense? Cool. How are others doing, guys? Could you just type in a quick Y or yes? I'll appreciate that. I only see Advait and Abhinav plugging in a few here. Ravi, okay. Okay, thank you, Pratyush. Okay, so that's again. So what we are trying to do is we're trying to get familiar with some of the main terms in the world of big data and things like that, guys. Okay, before we get into Hadoop and so on. So let me also proceed a little bit with this. See what we have here. Then we have what is batch data and real-time processing, guys. Okay, imagine you go to a bank and imagine you go ahead and withdraw maybe 100 rupees or $100 or 100 pounds from your ATM, guys. Okay, what is that? That's an example of real-time processing. Data is collected in real time. What does it mean? Well, as you withdraw or deposit your money, immediately the money is deducted in your bank account. It's happening real time. The data is delivered as it gets generated. Immediately you may get an SMS saying that, hey, your account is debited, and actually that amount is actually deducted or deposited from your account, guys. Okay, there is no time delay. Time delay is unacceptable because imagine you have deposited $100 and you don't see that reflected until maybe a few hours and things like that. What will happen? Well, we'll not be able to use that. That is unacceptable. What is that? That's an example of real-time data processing, guys. Okay, or you go to a retail store, you swipe a card. What happens? Well, you need to, in a second or 2 seconds, we need to the salesperson needs to get an acknowledgement whether you have the balance or not, right? What is that? That's an example of real-time processing. Then we have batch data processing. Imagine a bank, but this time imagine they are, what do banks do? Well, every week, every 2 weeks, every 3 weeks, they're running the reports. And what do? Well, maybe they're taking their historical data. They're trying to understand who are the customers who are happy, who are not happy, who are their valuable customers, and who's likely to churn and things like that. They're trying to find some interesting patterns and things like that. What do? Data is collected in batch at periodic intervals, every week, every 2 weeks, periodic interval, okay? There is a delay. We have to wait for some time. Certain periodicity is associated. And what do? Well, then they are taking the complete historical data and processing it. What is that? That is called batch data processing. Everybody with me, guys? Is that making sense? Gentlemen, ladies? Cool. Okay. That's batch data and real-time processing. And then we have data architecture, guys. Okay. So let's come here. Okay. So what is data architecture? It comprises of models, policies, rules, or standards that govern what data is collected, how is it stored, how is it arranged, how is it integrated, how is it put to use. Okay. So what do? Well, we have seas, we have rivers and oceans, right? What do? Well, we need to know how to get the fish from there. So that is why we have to understand how to store the data, how to transform it, and how to integrate it, how to process it, and things like that, guys. Okay, data is usually one of the key architecture domains that forms pillars of an enterprise architecture. Or more importantly, data is the foundation, guys. Okay, data is the foundation. Imagine you have a house. Your data is the foundation. On top of it, you build the pillars. Even though, per a formal definition, we are saying data is the pillar. Data is more really the foundation, and on top of it lies the pillars, guys. Okay, so that is a quick look at data architecture. Let's move ahead a little bit and see what is big data architecture, guys. Okay, it comprises of three broad components. The data, which is, no matter what size of data you have, how much data you have, how do you store it, how do you process it, how do you secure it, and things like that. Or in other words, your foundation is data. What do you do with your data? Well, you can go ahead and analyze data. What is all big data about? It's all about analytics, guys. Okay, what do we do? Well, we have fish inside the seas and oceans. What is business intelligence? Business intelligence is the process of going to rivers and finding the fish. That is the traditional way of doing the BI. When big data architecture comes in, a lot of predictive analytics, data science, and all these machine learning concepts are coming in, guys. Okay, so in other words, that's where more effective insights are being. We can get more effective, better insights, or more insights rather, by analyzing the big data. But again, we have problems with analyzing the big data, storing and processing, guys. Okay, what's the problem? We just discussed. To store the data, you have to be a mechanical engineer to drive a car. If really every driver has to be a mechanical engineer to drive a car, there will be a lot less drivers. So what's happening? That is exactly what is happening. People are today unable to process big data because they have to be experts in many other concepts, guys. Okay, so that's a little bit of analytics, a touch of analytics, but we'll talk more. And then what do we do? Once you analyze the data, you go ahead and visualize it. Whatever big data, whatever data you process, you have to share it with your other applications. And that's where it comes in the visualization tools and things like that. And that is what we mean by delivery and consumption, guys. Okay, implementation of analytics solution to the operational platforms, decision platforms, so that whatever we analyze, we need to make it available to other platforms so that they can make decisions, and in various ways. That could be real-time processing or batch processing or other ways in an interactive way, and things like that. They will be making decisions out of that. So that is kind of three components of a big data architecture from a high level, guys. Okay, everybody with me, guys? Is that making sense? I don't really expect you to become an expert in big data, but what I'm trying to do is I'm trying to get you slightly familiar with some of the important terms and things like that, guys. Okay, so just keep that in mind. Okay, so what I'm going to do is come here, slide 10. Gentlemen, ladies, we are at slide 10, and what we will do, let me also make a little bit progress on a couple of slides, and I'll go to my next step. So guys, okay, let's see what we have here. Okay, so we have different kinds of data, guys. Okay, we're able to get the data from different sources. What is that? Mainly data is classified into user-generated data and machine-generated data, guys. Okay, user-generated data is something where we go onto the blogs and we are entering as users. We may go onto Facebook, we may go onto our own blogs, or we are probably entering in our document, Microsoft documents and textual documents, and we are entering. What is that? That is called user-generated data. When we are, imagine, accessing our blogs, or maybe yahoo.com or gmail.com and things like that, what's happening? Your server, your Gmail, Yahoo's and things like that, they're recording a lot of data. The recording, what is the IP address that accessed? When you log into your Yahoo Gmail, they're recording your IP address, the date, the time, the resource you're requesting, what is the page you requested, what is the product you're looking at, and things like that. What is that? That is what is the machine-generated data or the application-generated data, guys. Okay, where does the data sit? That data sits in your log files. Okay, and then we have device-generated data. Today, IoT is becoming another important aspect, guys. Okay, what is IoT, guys? Internet of Things. What is it? Well, you have a lot of devices which are connected together. It could be a home, a bunch of devices that in your home, your microwave oven, your fridge, and all these things. They are capable of transmitting data. They can, as they transmit data, the data is getting accumulated in central servers. What is that? Well, what's happening is big data. In very small amounts of time, huge amounts of data is getting generated, guys, okay? What is that? Since the devices are generating the data, that is called device-generated data. A traffic, for example, is one example of device-generating data. And point of sale, indicating, what products you have added to your cart and things like that, and what you're purchasing and things like that is point of sale. Internal data, any data which is your internal to your organization. This is the reverse of the world, guys, okay? These things, these three, these are the seas and oceans. This is the reverse of the world. Any data which is internal to your organization, in your database. You may have a sales application, we may have a logistics application, a finance application, and things like that. This is the data that is stored internally within the organization, and this is generally where we are going ahead and finding the fish. Okay, that is called referred as internal data, another place where we get the data, right? Then we have external data. Imagine you're a credit bureau, you're a credit card company. What does credit card company do? Well, they are offering credit cards, and what do they do? Well, a person when they apply for loan, they want to understand, they won't look at his credit history. What will they do? They'll hook up with a credit bureau and say, hey guys, we need you to check this credit history of this guy. We do not maintain the credit history. So you tell us if he's good or not. And based on that, we will go ahead and issue the credit card to them. What is that? That is referred as external data. Okay. So in other words, we are getting the data from some of our external partners is one thing. Okay. If I clean this up a little bit, this, come here. This is the seas, or rather this is the rivers of the world. The rest of it is the seas and oceans of the world, guys, okay? So what do we do? Well, you can get your water from rivers. You can find your fish in rivers. Today, what they're doing, the disruption is, there's another place. There's a new kid on the street. That is the seas and oceans where we can find more fish, guys. What is fish? Fish is insects. Everybody with me, guys? Am I making sense? Cool. Great. Okay, now let's take another look at an example of some of the fish and the insights that we've been talking about, guys. Okay, imagine we have a database. Traditionally, what we do well, we'll say we have a woman. That's a gender. She's single. She's not married, and she's probably between that age, and that's her income. This is kind of the information that we traditionally save in our database, guys. Okay, what do you make out of that? Well, that is referred as demographic overview. You have an idea of what is her age range and salary and things like that. But that is the data, that is what you can get out of your rivers. Now here's what we have in the seas and oceans. Imagine you go to her Facebook or maybe some other social networking sites where she's constantly going ahead and chatting and things like that with her friends. What can we do? Well, imagine we analyze it. What do we do? Well, now we understand she loves to travel. How? Well, maybe she's saying, hey guys, I went to New York, I went to Paris and things like that. What does that mean? Well, you're inferring. You can understand something out of that. She's interested in travel. So what do we do? Well, next time when she comes on to other sites and things like that, what can we do? We can shoot the right ads. We can say, hey, here's a much more cheaper, a better airline and a cheaper rate that you could travel, right? That is one thing we could do. Maybe she's also talking about subscription of a fashion magazine. Maybe that's a spend capacity. So what do we do? Well, next time she comes on to another site, we could probably show her another ad saying, hey, you can get an annual membership here at a cheaper, pardon me, at a cheaper price. Okay, or maybe you can get a fashion magazine at a cheaper price and a better quality and things like that. What is that? That is the insight, guys, okay? That is the insights that companies are interested in. They are trying to understand what you like, what you don't like, and what is it you'd be interested in purchasing and not purchasing and things like that. And what is that? That is called psychographic information. Am I making sense, guys? Everybody understand, guys? So these are the fish that we can get from the seas and oceans. This is the fish that we can get from rivers. What's happening? 80 to 90% of the data is there. 80 to 90% of the rivers, of the water is there in the rivers. What is that? That is unstructured data. But in there lies a lot of useful insights that the companies can make use, guys. Okay, gentlemen, ladies, am I making sense, guys? Could you give me one more acknowledgement, please? Okay, cool. Okay, so what we'll do today, guys, I'm at slide 11. Let me just go ahead and pause here for a second. And the next 5 minutes, what I want to do is, in the interest of those who have missed a couple of sessions, let me bring up the course content. Okay, so here is the course content, guys. Let me go ahead and share it. Okay, so here is my plan for the next 6 weeks. We have just started the big data and Hadoop introduction. We have just focused on talking about big data. We didn't really get into Hadoop yet. On a daily basis, I'll be taking anywhere from 1 hour to 1 hour 15 minutes to maybe 20 minutes, like that, guys. 8 to 9:15, 9:20, and here and there sometimes maybe I may go up to 9:30 is what my plan is, guys. Then that is week 1. Then we'll slowly get into the internals of the Hadoop architecture. We'll then get into MapReduce concepts and advanced MapReduce concepts. I will expect a little bit of Java, or rather, this advanced MapReduce concept is mostly for the Java folks, guys. Okay, this is the only place where I expect a little bit of Java. But the rest of them, even if you do not have an idea of Java, that is okay, guys. Okay, so just kind of keep that in mind. That is what we'll be covering in the second week. We'll also discuss about Yarn. Then we will go ahead and start discussing about PIG, some advanced PIG concepts, Hive and advanced Hive concepts, followed by HBase, which is an NoSQL database, followed by Scoop, and followed by Flume. Here are some of the use cases and the projects we'll be covering, guys. Okay, so actually, that's a final project, which is a sentimental analysis project, a healthcare project, a banking or a finance, banking domain or a finance use case, recommendation engine, and telecom domain project. These are the use cases, or rather the projects, that we'll be covering as part of this course, guys. Okay, this is for those of you who missed my initial sessions as to what I would be covering and things like that. Here is a detailed content of the topics. So that is in week 1, week 2. Let me go ahead. Okay, advanced MapReduce concepts. I may go ahead and actually skip this advanced MapReduce concepts till the end, guys. Okay, I will interchange. I will first probably cover PIG and Hive, and then I'll come to advanced MapReduce concepts, and that is the only place where I'll expect a little bit of Java. But if you're not much into Java, you can skip that. And we'll also discuss how to go ahead and do the same things without Java. Whatever we do in advanced MapReduce or MapReduce way, how we do it using PIG and Hive, we'll try to understand. So here are some of the detailed things that we will be covering. Social media project, healthcare project, finance, and recommendation and telecom project. These are some of the things that we will be covering, guys. Okay. Spark and Scale. Okay, Srinivas, I understand. Gotcha. Yeah. So probably I'll plug in a few more sessions for Spark and Scala also, Srinivas. It's probably not going to be a full-fledged one, but I will try to help it. I was not sure if you are here today. Hadoop admin. Okay, Hadoop admin. All right, yeah, I think I can do that. So Pratyusha, I will not promise you Hadoop admin, because that kind of plugs in a little bit of different this thing. But I will keep that in mind, Pratyusha. At this stage, I cannot promise you because of reasons, but I will keep it in mind. And if should I decide, I will definitely keep you posted, Pratyusha. Okay, allow me to take that freedom. And PIG and Hive, no, you don't need Java for PIG and Hive, Tarun. You leave that to me. That is magic. I will work out. Without much of Java, you should be able to. And that is the very intention of Hadoop. Without getting into too much of Java, that's where PIG and Hive come to your rescue. How do we? Okay. Another thing is, I think these are Srijan. I think these are things I shared in the previous one, but I will share your virtual machine. Let me go ahead and see if I'm able to bring that up here. Bring it up. So in the virtual machine, I have everything hooked up. I have all our exercises and everything is already hooked up here. Okay, so let me go and resume that. And what we'll do is, every day I will do a little bit of labs and a little bit of starting probably after 2 or 3 sessions, I will also start getting into labs. We'll spend a little bit of, until Pig and Hive, I will do maybe 40% of labs and 60% of theory. But once Pig and Hive start, that's where it's going to be the reverse. 60 to 70% is going to be lab, and probably 20 to 30% is going to be theory. Srujan, but this is the VM that I will be sharing with you. Let me go ahead and get in here. And there is training. In training, there is data science. So here are the labs. So I have everything hooked up here. So HDFS commands, then comes the MapReduce, then comes the advanced MapReduce, then comes Hive. Those are all the Hive examples and use cases. That is a pick. And that is Scoop. After Pick, it's going to be 60 to 70% is going to be practical, and 30 to about 30% is going to be theory. Until Pick, maybe 60% theory and 40% roughly labs is what I will be doing, Srujan. So that is Flume. That's a little bit about HBase, and that's the final project. And I also have my banking and finance project somewhere over here. There is a banking project, and there is a telecom project. So these are all the files and things like that that I will be covering, guys. Okay, they should give you a pretty decent idea, or actually, to be frank, they'll give you a very good idea as to what you'd require more from a real world, how things work out in a real world, from a Hadoop perspective, how multiple things work together and things like that. Okay, so that is for those of you who missed the earlier sessions, guys. Okay, apart from that, any other questions, guys, you want me to verify or clarify and things like that? I will probably add a little bit of Spark and Scala. That will probably end up being a little bit. I may have to give a thought. Yes, you can, this is actually Cloudera Quick Start and it's version 2.0. Srujan, that is true. But it's slightly modified. In Cloudera Quick Start, you need 8 GB RAM, whereas this one will also work with 4 GB RAM. I picked it up from my work so that everybody can use it. You don't need 8 GB or 16 GB RAM here. Although I'm using a 16 GB RAM, guys, okay? But again, Cloudera Hortonworks is different. If you know how to drive an Ambassador car, whether it's a BMW or a Benz, you'll be able to drive it. So what I'll teach you is an Ambassador car, and Hortonworks and Cloudera, will be secondary for you. That's cool. Dual processor should be cool, should be good. Okay, no problem. Let me just unmute our friend Srujan here. You're on air, Srujan. Go ahead, buddy.
Navin, we use a MacBook here and the Windows laptop as well, but none of them have got beyond 8 GB RAM. So if your system got installed these things on your laptop or somewhere, how could we access them?
If you already have Windows.
Yeah, I do Windows, but it's 8 GB RAM.
Oh, yeah, that's more than enough. Even if you have 4 GB, it will work, is what I was conveying. So 8 GB is pretty good. And all you need is a VM player. What I have here is a VMware, but what you need is VM player, which you can download for free. And let me see. Oops, go here. You should be able to download. Am I answering your question?
Yeah, very much indeed.
Cool. Okay, so this is where. Go ahead.
So, and I actually founded a company called Diagonal Metrics, and that company is a consulting partners with Salesforce, Cloudera, Hortonworks, and MapHart. So we get a complete help from them. So by any chance, during our learning, can the team and can we get help in terms of resources or in terms of platforms, this thing, which we sometimes, if you think, you know, that can be only possible in the live environment, not through the system, is something a showstopper, then you know, I would be happy to seek your help on that.
Sure, sure. I mean, yeah, I think I'll definitely give you direction. I may not be able to kind of sit with you and work together, but I'll definitely share the opinions and kind of the expert opinion and give you the direction if that sounds okay to you. Should you need more help, I will kind of, we'll plan it out, Srijan, how we...
No, it's not. Sorry, my question was, it's not my personal help. For example, there are certain areas where that exercise requires a practical environment. Not these trial systems might not support us. So in that case, our partnering thing would help us to get the access to the sandboxes. So if that is something you needed, I would try to get the thing. So it's a great opportunity for us to learn from you out of your experience. That's all.
Yeah, outstanding. That's really good. I really appreciate that, Srijan. If you're able to take our thing a little bit ahead and kind of give everybody a little bit more of real world touch of it, that would be great.
Yeah.
Am I addressing your concern or rather question, Srijan?
Yeah.
Okay.
Yeah,
I think you're actually trying to help out everybody, and you're kind of proposing something.
No, well. It's not. Honestly speaking, it's not about helping. It's about getting the maximum out of your knowledge.
Gotcha. Okay. Sounds good. I should be flexible. I'm generally doing that with other folks, so I should be able to kind of give you some direction and things like that. That's Srijan.
Yeah.
Cool. Great. Thank you, buddy. Appreciate that, Srijan. So let's see where we are. Okay, so that is Srijan, guys. Gentlemen, ladies, any other questions for today before we wrap up, guys? Let's see. Okay. How much RAM? About 4 GB will also work, but the more the better, is my personal opinion, because generally, the more the better, right? As simple as that. Okay. So, guys, gentlemen, ladies and gentlemen, again, thank you very much for your cooperation today. And we will regroup tomorrow again at the same time. I will try to continue and take it from here, guys. Okay. So, the once you get finalized on your formalities and things like that, we will go ahead and share the virtual machine and all the presentation material and things like that. And Srijan has another one, share a document or something to install Cloudera. Okay. Should be pretty straightforward, Srijan. I will probably go ahead and have a quick, I'll show it to you real quick how you do that. All you need to do is download my virtual machine and just install the VM player, and you should be able to open it. But we'll do that maybe tomorrow, day after tomorrow, like that in a day or two when I get to the labs and things like that. Cool. Okay, great. Okay, Tarun, I'll forward it. I think I have already forwarded this to our support folks, but I will check with them and forward it again to them, Tarun. Okay. Okay, yes, so me to sign off here for today. You guys take care, and I look forward to meeting you tomorrow. Thank you, and bye for now, guys.